Hi everyone, I'm Michael, and my project was on analyzing the combined exposure of extreme heat and dust at California's Salton Sea through a lens of public health. Now, I know for me, the Salton Sea has meant a lot to me ever since I first learned about it in my freshman year of high school. But what is it exactly? Well, it's a high salinity artificial lake in Imperial and Riverside County, and it was created in 1905 from a routing accident along the Colorado River, where river water was being diverted, and there was an accident that led to the Great Salton Basin filling with water over a period of 2 years before repairs could be completed. And people thought that this new Salton Sea was going to dry up and evaporate really quickly, but no, it persisted. And it actually became a booming resort hub for people to go on vacation at. And places like Bombay Beach here were actually thought of as potentially being the next Palm Springs. It was that popular. But unfortunately, the Salton Sea gradually became polluted from farm runoff from the surrounding agricultural industry. And this resulted in people fleeing the area and the entire tourism industry drying up dramatically. And it also led to mass ecosystem collapse for the entire Salton Sea ecosystem. Now, I know when I learned about this in high school, I was motivated to one day investigate this and try and come up with solutions for the Salton Sea to try and restore it to its former glory. Now, the Salton Sea has also been drying up more recently due to two main factors. One is the long-term decline of the Colorado River due to Western U.S. climate change trends, but more significantly is the 2003 Quantification Settlement Agreement. Now, this was the largest agricultural to urban water transfer in U.S. history, whereas an agreement between San Diego and Imperial counties that transferred all that agricultural water that had been sustaining the Salton Sea to San Diego in order to support its growing communities. And the Salton Sea's decline was a known byproduct of this. Now, this is really concerning because the Salton Sea receding, as we can see, it accelerates after that agreement was signed in 2003. It poses significant air quality hazards because the sea is so polluted that toxic dust is then exposed to the elements and then can interact with dust storms and then spread throughout the region, which really lowers air quality for the locals. So the main issues at hand that I really wanted to investigate here is that I was really concerned about disproportionate health impacts on vulnerable communities in the area and around drying saline lake ecosystems in general. And this was really an important issue of environmental justice and health equity to me, because these populations that are the most affected are often the ones least responsible for the things that are driving it. So the really low income areas around here are the least responsible for historical carbon emissions compared to richer areas like San Diego County that are driving climate change. And they also had very little say into water management policies like the 2003 QSA. And really, I just thought this project would serve as a case study for compound exposure of extreme heat and dust around these drying salt lake ecosystems as they decline. So think of other areas like Lake Abert in Oregon or the Great Salt Lake in Utah. This is an issue that we're going to be seeing a lot more of as these lakes decline as climate change gets worse. And specifically looking at compound exposure, it's important because the combined effects of dust and heat exposure results in a synergy where the total environmental hazard posed is a lot greater than just the sum of their individual parts. It has been associated with oxidative stress, a heightened systemic inflammation, and impaired thermoregulation in people, where their heart and lungs have to overwork to maintain themselves. So the main research questions I want to investigate were, how has compound exposure to extreme heat and dust in California's Salton Sea evolved over time? What areas around the Salton Sea are most affected by compound exposure? And is compound exposure of extreme heat and dust disproportionately impacting more vulnerable populations? So what data did I use to go about this? Well, I first consulted the CDC's Social Vulnerability Index. Now, for those who don't know, a Social Vulnerability Index is a scale from 0 to 1, with 1 being the most vulnerable and 0 being the least vulnerable, of essentially how prepared a community is for a natural disaster of some sort. So think of like a tornado or even the pandemic that we all just experienced, or a hurricane. It's essentially a measure of how much outside help that area will need and how disadvantaged they are relative to everyone else. I also consulted two proprietary data sets for daily average temperature data and then biweekly dust concentration for PM 2.5. I also used publicly available data sets for census tract layers for the mapping part of this analysis. So what was my methodology? Well, I limited my study period from the beginning of 2005 to the end of 2022 because that was the range my data that I was provided with ended in. And then my study region was the 157 census tracts that are surrounding the Salton Sea that comprise the whole region. All of my compound exposure maps and graphics were coded in RStudio, which is a software development environment. And then all the asthma analysis maps I made were created in ArcGIS, which is a mapping software program. So what are the main analysis definitions to really understand here? Well, when we talk about compound exposure of extreme heat and dust, it's important to set cutoffs so that we know when compound exposure is occurring. So I created two. I did lower joint exceedance and higher joint exceedance. Now, I defined lower joint exceedance as when there's at least 1 day above 89.6 degrees Fahrenheit, or the 85th percentile for the whole region. And in that same biweekly period that's occurring, the overall dust concentration has to be above the 75th percentile. Now, for higher joint exceedance, there has to be at least 4 days above that roughly 90-degree threshold, and then the dust concentration level has to be above the 90th percentile. I also created a dust heat index to see how compound exposure is evolving over time, and it basically resulted in me having to multiply each biweekly dust data point together with the number of extreme heat days in order to get that index. I also separated all of my findings by 2014 social vulnerability index quartiles, so we had 4 groups in total from the CDC data, and this was done in order to assess any disproportionate impacts on communities in the region. And I specifically picked the 2014 data because that fits right in between my study period of 2005 to 2022. So what were my results? Well, here we have a map showing the mean annual extreme heat days in the region. Now, the main takeaway here is that the entire eastern part of the region experienced much warmer than average temperatures a lot more often than the west, especially the northwest. Specifically here, that reddest tract that you see on the lower right, that tract is approaching nearly 80 days out of an average year in my study period that are above that roughly 90-degree threshold for daily average temperature. It's very concerning. And then the spatial pattern we observe for dust concentration is even more stark, where air quality is significantly worse in the southern part of the region for tracts that are directly south of the Salton Sea. Now, this pattern is so distinct that it really begs the question, why are we observing this? Well, it makes a lot of sense when you realize that the Salton Sea is surrounded by 2 mountain ranges, the Chocolate Mountains on the east, and then the Santa Rosa Mountains on the west. Now, these act to create a wind tunnel of sorts, so all the dust in the region is blown from the northwest to the southeast and then settles in those tracts that are directly to the south of the Salton Sea. And this poses significant air quality hazards for locals. Now, if we bring a disproportionality analysis into it, where we examine those 4 quartiles of social vulnerability, we see that that most vulnerable part of the population in red is experiencing significantly elevated dust levels relative to the other 3 segments of the population. This really reinforces this whole issue as one of environmental justice and health equity because they have to contend with worse air quality. Now, if we look at the actual combined exposure of heat and dust together, here's a map of the frequency that we observe over the study period for compound exposure being met. And we see a really similar spatial pattern to the dust map that was presented earlier, where that seems to be the primary association that could potentially be driving compound exposure in the region. But then if we overlay a social vulnerability index with this map, we can essentially look at how social vulnerability index, which is mapped on the y-axis for color coding, and then the cumulative burden of compound exposure, which is mapped on the x-axis, see how that varies on a tract-by-tract level. And the main thing to take away here is that the intersection of these two is going to be that dark blue region, where those areas are the most socially vulnerable, but then have the highest level of cumulative burden for extreme heat and dust. And it really shows how those same tracts, a lot of which we already observed in that prior frequency map, are really the ones that are the most disproportionately affected, even though they are so vulnerable. Then if we look at that heat-dust index I mentioned earlier, 2 key findings emerge. One is, again, that upper 4th quartile of the population, the most vulnerable segments of this community, are experiencing significantly elevated levels of compound exposure relative to everyone else. But we can also see that compound exposure is also increasing over time. There's a notable upward trend here where compound exposure has increased over my study period. And that makes a lot of sense because climate change has been getting worse over the 2005 to 2022 study period, but also the Salton Sea has been receding, so more of that lake dust is then exposed to then worsen air quality for the region. So it makes sense that we'd see this trend. Next, I wanted to really investigate and put numbers on the actual disproportionality for how different segments of the population are affected by this. So I did a disproportionality analysis. The main takeaway here is that the relationship observed is that the highest segment of the population for social vulnerability is now bearing 26% greater compound exposure periods than they ought to, given their portion of the population. And this is important because the Salton Sea region already skews toward that fourth quartile, with nearly 33%, or a full third, of census tracts that I observed for the study period being within that most vulnerable quartile. And then this gets even worse when you look at that higher joint exceedance level, where now at these more outlier scenarios for more extreme heat and dust events, that same segment of the population is now bearing 42% greater compound exposure periods than they ought to. And it again reinforces how big of a environmental justice issue and health equity issue this really is. Next, I really wanted to investigate what are the primary demographic predictors that are driving this disproportionality. So I examined socioeconomic status, household characteristics, racial and ethnic minority status, and housing type and transportation. Now we can see that all four of these sub-themes are displaying similar trends to what we observed before, but none more so than for racial and ethnic minorities, where the most vulnerable minorities in the region are bearing 47% greater compound exposure periods than they ought to. And a quick note on the upper right section for that blue quartile, that is the result of an outlier where only 2% of census tracts in the study period actually fall into that, but then they bear about 3% of compound exposure periods. So you get like a skewed result there. But then if we observe the higher joint exceedance level for these subthemes, we can see that the relationship observed gets stronger for all four of them, but none more so than for racial and ethnic minorities, where the most vulnerable minorities are now bearing 66% greater compound exposure periods than they ought to. It's a big issue of health equity, once again. Next, I wanted to examine the actual felt health impacts of all of this. So I clipped out all of the California census tracts in SoCal that are above the state average for asthma rates in adults. And we can see that a lot of the census tracts around the Salton Sea are represented here, but specifically, a lot of them are displaying some of the highest rates of asthma in the state, upwards of 15%, which is just really concerning. And it also aligns well with the prior dust concentration map we observed earlier. But then if you want to investigate disproportionate effects on poor populations, we can then clip out tracts that are above the state average for asthma, but also below the state median household income level. And the pattern that emerges when you sort by income level is that a lot of those same tracts remain from the prior map, but a lot of them are the most lightly shaded on this map, meaning they're the lowest income areas around the Salton Sea. So you can see that they bear a lot of the highest rates of asthma, but are also some of the poorest people in the entire state. It's just really concerning from a lens of health equity. So what are the main conclusions that we can draw from all of this? Well, the main one would be that compound exposure is increasing over time as a result of that dust heat index we observed. The southern region that's downwind of the Salton Sea is one that is hit hardest by compound exposure events for extreme heat and dust. The most disadvantaged communities, such as racial minorities specifically, are bearing the highest rates of co-exposure, especially at that higher joint exceedance level for those outlier events. And then finally, low-income communities that are exhibiting the highest rates of asthma, disproportionately so around the Salton Sea region, which is really concerning if you care about environmental justice and health equity, as I do. So what are the main limitations for this study? Well, pre-2005 and more recent years aren't being represented, which could provide a more holistic overview of how this trend has evolved over time. And then the wider Southern California geography is also not really being analyzed as much. Well, that could have provided a significant contrast to the Salton Sea region itself to sort of highlight how unique the public health crisis at the Salton Sea really is. And I think the most significant limitation is that while I chose that 2014 SVI because it fits right in the middle of my study period, it's not as up to date with modern social vulnerability indexes, and thus can't be really used for current policy debates for decisions for what to actually do about this health crisis. So speaking of which, what is some future work that one may want to do when after having established this unique public health crisis at the Salton Sea. Well, again, that follow-up study with data from more recent years and prior to the 2003 Quantification Settlement Agreement could provide very useful analysis and a holistic overview here. But specifically, while I've shown a lot of correlation and association between proximity to the Salton Sea and greater compound exposure events, actually proving causation, showing that the Salton Sea's recession is driving these events, would require tracing dust from the Salton Sea lakebed to the surrounding region. And there's been some really exciting preliminary work investigating this, but for this study, that's what would have to be the next step. And finally, I think an investigation into the optimal restoration and mitigation solutions would really be warranted here to actually fix the problem now that we've identified it. You can see on the right here, I have a proposal for water optimization by Mr. Michael Cohen of the Pacific Institute, where he's proposing taking the higher quality inflow water into the Salton Sea and redistributing it via a system of canals into man-made lake beds and ponds around the Salton Sea region. And this would be done before that water can mix with the briny center of the lake and degrade. Now, this would serve two dual functions. One is that it would serve the obvious benefit of ecosystem restoration, but then it would also cover that exposed lake bed so then the dust cannot be kicked up by the winds and then degrade local air quality. It's a really interesting proposal, and I had a great time talking to him about it. So I just want to thank my amazing capstone team, Dr. Alexandra Heaney of UCSD Public Health, Dr. Corey Gabriel, and then also Dr. Wenxin Liu of UCSD Public Health for the dataset analysis portion. Are there any questions?
Thank you, Michael. Great presentation.
Thank you so much.
Interesting work, and I like that the impetus for it all was something near and dear to your heart. When you're looking at the Salton Sea and you're looking at the past 20, 25 years, what type of policy implementation or adaptation at the jurisdictional or individual level have you seen? Or are we really just dealing with the hazard as it comes?
So there has been some significant progress more recently. So recently on the southern end of the sea, the species conservation habitat for ecosystem restoration has been established by the state, and it was actually broke ground last year and was completed very recently. It's a really significant development because there's been a lot of years of inaction on that problem. But there's also been some mitigation efforts done at the area to actually reduce dust exposure. And this main one has been placing hay bales out on exposed lake bed to limit how much dust can be kicked up. Now, a lot of locals don't really like that because they think it looks weird and they just kind of have a general distrust of government. But those are the two main things that come to mind for what the state is doing about it. But of course, there's a lot more interesting proposals, like I just mentioned, that we could be doing instead as well.